Good day, everyone. Before we begin our discussion, let me ask you a quick question. Have you ever wondered why a string moves back and forth or why a guitar string vibrates when plucked? Those are examples of oscillating systems. An oscillating system is any system that moves repeatedly back and forth around a central or resting position, like pendulum, a spring, or even sound waves. In this presentation, we'll learn how to relate the amplitude, frequency, angular frequency, period, displacement, velocity, and acceleration of this oscillating system. Now let's begin. Let's start with amplitude. Amplitude is the maximum distance an object moves from its resting or equilibrium position. It shows how big or strong the oscillation is. The larger the amplitude, the more energy the system has, since energy is proportional to A squared. Now, think about this. When you push someone higher on a swing, what happens? Right, the swing goes farther from the center. That means it has a larger amplitude and also more energy because energy increases with the square of the amplitude. In sound, amplitude determines loudness. A soft whisper means a small amplitude, while shouting means a larger amplitude. So remember, the greater the amplitude, the stronger the motion and the higher the energy. Next is frequency. Frequency tells us how many complete cycles or oscillations happen in 1 second. It is measured in hertz, where 1 hertz equals to 1 cycle per second. A higher frequency means the motion repeats faster. Here's a quick question. If a swing moves back and forth twice every second, what's its frequency? If you answered 2 hertz, you're right. That means 2 complete cycles per second. And if we relate it to sound, higher frequency gives us higher pitch sounds like a whistle, while lower frequency gives lower pitch sounds like a drum. Now, let's move on to angular frequency, symbolized by the Greek letter omega. Angular frequency measures how quickly the object goes through each cycle, but instead of cycles per second, it's measured in radians per second. It connects frequency to circular motion because 1 cycle corresponds to 2 pi radians. Here's something to think about. If 1 full cycle is equal to 2 pi radians, how do you think angular frequency is related to frequency? Exactly, they're connected through this formula. Angular frequency is equal to 2 pi f or 2 pi over time. For example, if f is equal to 2 hertz, then angular frequency is equal to 4 pi radians. That means the object completes 4 pi radians of oscillation each second. We often use angular frequency in physics and engineering because many oscillations behave like circular motion, just projected in a straight line. Now, what about period? The period is the time it takes to complete 1 full oscillation or cycle. It is measured in seconds, and it's the inverse of frequency. T equals to 1 over f. A shorter period means faster motion because cycles finish quickly. Here's a question for you. If an object has a frequency of 2 hertz, what's its period? Right, it's zero point 0.5 seconds, meaning 1 cycle takes half a second. Think about a pendulum clock. The steady back and forth swing has a fixed period, which helps keep accurate time. Next is displacement, represented by x. Displacement tells us the position of the object at a certain time relative to its equilibrium or resting position. It can be positive, one direction, or negative, the opposite direction. The formula is x of t equals a cosine of omega t plus phi, where a is the amplitude, omega is the angular frequency, and phi is the phase angle. For example, if a spring is stretched 0.2 meters to the right, that's positive 0.2 meters. If it's compressed 0.2 meters to the left, that's negative 0.2 meters. Now, here's a thought. If we take a picture of the object mid-motion, what does that show? Exactly, that's its displacement at that moment, a snapshot of where it is in its oscillation. Next, we have velocity. Velocity describes the speed and direction of the object's motion at a given time. The formula is velocity of t equals negative amplitude times angular frequency times the sine of angular frequency t plus phi. Velocity is maximum at the equilibrium position because that's when the object moves the fastest. Velocity becomes zero at the extreme positions, amplitude points, because the object stops momentarily before changing direction. Think again about the swing. It moves fastest at the middle and slows down at the highest points. So when it's at the top, velocity equals zero. At the center, velocity equals maximum. Now, let's talk about acceleration. Acceleration is the rate of change of velocity showing how quickly speed or direction changes. The formula is acceleration of t equals negative amplitude times the square root of angular frequency times the cosine of angular frequency of t plus phi. Acceleration is largest at the extreme positions because that's when the restoring force pulling it back is strongest. At the equilibrium point, acceleration is zero because the object is moving smoothly without being pulled back strongly. Think about this. When a pendulum reaches its highest point, what's trying to pull it back? Right, gravity. That's why acceleration is greatest at those turning points. Now that we know all the parts, let's see how they connect. Amplitude sets the limits of motion. Bigger amplitude means bigger displacement, velocity, and acceleration. Frequency and period are opposites. If one increases, the other decreases. Angular frequency ties them together using radians. Displacement tells us position. Velocity follows displacement, maximum at the center. Acceleration is opposite displacement, maximum at the ends. Together, these quantities form a repeating cycle. As one changes, the others follow. That's what makes oscillating motion so beautiful and predictable. So that's all about the key quantities of oscillating systems: amplitude, frequency, angular frequency, period, displacement, velocity, and acceleration. Each plays a role in describing how motion repeats in a beautiful rhythmic pattern. Thank you for listening, and I hope you now have a clearer understanding of how these quantities are all connected. Bye bye.